Hello everyone and welcome to day 20 of our low-level design course. Today's session is particularly exciting because we will be learning two behavioral design patterns that are extremely powerful in real-world software development, the template method and the state pattern. By the end of this session, you will be able to identify real scenarios where these patterns shine and even implement them with confidence. So let's dive right in. Before we start, let's get clear on our goals for today. First, we will thoroughly understand the template method and state patterns, how they work and where they are used. Second, we will see how to apply them to real-world software design problems, not just theoretically, but practically. And lastly, we will practice implementing these patterns through UML diagrams and code examples. This structured approach will help you not just learn, but truly internalize these design concepts. Just to quickly set the context, remember that behavioral design patterns are all about how objects interact with each other and how responsibilities are distributed. They are different from structural patterns, which are about how classes are composed, and from creational patterns, which are about object creation. Behavioral patterns like template method and state focus on the flow of control and dynamic behavior in our applications. Today's patterns will empower your code to be more adaptable and resilient. Let's start with the template method pattern. Imagine you have an algorithm or a workflow that should remain consistent in structure across multiple classes, but where a few specific steps vary. Instead of duplicating the overall logic in each class, we define a template, a base method that sets the steps in order. Subclasses can then fill in the specific behavior by overriding only those parts that differ. This promotes both code reuse and consistent execution flow. A simple but powerful real-world example is making coffee or tea. The process looks like this. First, you boil water, then brew the drink, pour it into a cup, and finally you add condiments. While brewing coffee and tea involve different processes, steeping tea leaves versus dipping ground coffee, the high-level steps remain exactly the same. That's the essence of the template method. Tweak the structure, allow flexibility where needed. Looking at the technical side, the abstract class defines a method that calls several operations in sequence. This method is our template. Some operations are implemented directly into the abstract class, but crucial ones are left as abstract methods, meaning subclasses must implement them. This gives a nice balance of fixed flow and customizable steps. In the next slides, we will look at UML diagrams to make this even clearer. Here's a quick Java example to bring it to life. The abstract class caffeine beverage defines a method called prepare recipe. This method outlines the sequence boil water, brew, pour, add condiments. But the brew and condiment methods are abstract, allowing subclasses like tea and coffee to fill in the specifics. Notice how subclasses focus only on the differences. They don't worry about the boiling or pouring steps. Now, when should you use the template method pattern? Anytime you have a set of classes that share a similar sequence of operations, but where certain steps might be different across implementations, it eliminates code duplication, enforces a uniform structure, and promotes cleaner, more maintainable code bases. It's especially useful in frameworks, SDKs, or anywhere you are providing a customizable workflow. Alright, let's pause here for a quick 10-minute break. Use this time to stretch, grab a cup of coffee or tea, maybe even observe the template method in action at your coffee machine. We will regroup shortly to explore the state pattern. Welcome back. Let's switch gears and explore the state pattern. The state pattern allows an object to alter its behavior when its internal state changes. It's like the object's class itself changes at runtime, although technically it's the behavior that changes, not the class. Imagine using an ATM. When you approach it without inserting your card, it prompts you to insert one. Once you insert your card, it transitions to a card inserted state and asks for your PIN. After entering the correct PIN, it transactions again and allows you to perform operations like cash withdrawal. Each state, no card, card inserted, authenticated, controls the available operations. That's the magic of the state pattern. Behavior changes based on the object's state. From a technical perspective, the state pattern has three core elements: the context, which holds a reference to the current state, the state interface, which defines the behavior, and the concrete states, which implement specific behaviors for each state. When the context's internal state changes, it simply delegates to a new concrete state without altering the code's logic flow. Extremely powerful. Let's look at a Java code example. Here we define a state interface with actions like insert card, eject card, enter pin, and withdraw cache. We then have a class like noCardState implementing the state interface. When you call insert card on the context in this state, it responds appropriately, maybe transitioning to the hash card state. The important takeaways is the context delegates behavior to the state object. This removes all the complicated if else or switch logic you would otherwise write inside the context class. You should use the state pattern when the behavior of an object depends heavily on its internal state, and it's cleaner to represent each state as a separate class. It prevents bloated, hard to maintain code that's filled with multiple conditions. It's perfect for systems like vending systems, elevators, game levels, or any scenarios where an object's behavior must change dynamically. Let's apply what we have learned. Think about a traffic light system that states are red, yellow, and green. Sketch the context and the three different states. Try to model how transitions would happen and how behavior changes. For example, at green, allow traffic; at yellow, slow down; at red, stop completely. To wrap it up, the template method pattern is all about defining a structure once and allowing subclasses to tweak specific parts. It encourages code reuse and standardization. The state pattern, on the other hand, helps us manage dynamic behavior changes without messy conditionals. It enables clean separation of concerns, making code easier to extend and maintain. Both are essential tools for building flexible, maintainable, and professional grade software. For practice tonight, try designing a food delivery flow using the template method. Define the overall delivery process and allow different types of orders to customize steps. Also, model a washing machine's operational states using the state problem. Think about washing, rinsing, spinning, and how the machine should behave differently in each mood. That brings us to the end of today's session. Thanks for staying engaged and participating actively. Remember, understanding patterns deeply is a gradual process. Don't just memorize, practice applying them to small systems you design. Thank you for your attention.